Okay, um, good afternoon, everyone, and welcome to the DEP's celebration of Air Quality Awareness Week. My name is Louis Lim, and I am an engineer in the DEP's Division of Air Quality, working to monitor the air in New Jersey. I am taking questions today about air quality, ozone, and air toxics. As many of you know, ground level ozone is a pollutant that forms in the troposphere, the lowest layer of the Earth's atmosphere, by the reaction of industrial and motor vehicle emissions. In the presence of warm temperatures and sunlight. Ozone can irritate lungs, and persons with lung-related conditions should take precautions when ozone levels are forecast to be high. The ozone that is harmful for our lungs is the same ozone that is found in the stratospheric ozone layer 15 miles above the surface of the Earth, where it protects living things from the sun's ultraviolet radiation. Air toxics are pollutants that cause or may cause cancer or other serious health effects. The US EPA classified 187 pollutants as hazardous air pollutants, and industries that use or emit these pollutants need to follow many rules and regulations. Common examples of air toxics are benzene, formaldehyde, methylene chloride, toluene, and xylene. These can also be found in household items such as fuels, paints, wood preservatives, disinfectants, and pesticides. So I think we can start with questions. Let's see, I'm just waiting for some questions. Okay. Here we have a question. Is ozone the same as smog? Smog is an old term combined from the words smoke and fog. And smog was used to describe air pollution that lowered outdoor visibility. In the past, the pollutants that in smog were particles and sulfur dioxide that were emitted by coal burning. Today, when you see hazy, polluted skies, the pollutants are now ozone, nitrogen dioxide, and particles that are emitted from power plants and motor vehicles. You can still say smog or smoggy, but what makes up the pollution in smog today is different from what it was in 1950. Okay, let's wait for another question. Diane Smith asks, where does air pollution come from and how does it contribute to global warming? If so, how can we prevent it? So air pollution comes from power plants, industrial facilities such as factories and chemical plants. It also comes from motor vehicles, and a lot of consumer products. For example, wood preservatives or disinfectants. A lot of chemicals that vaporize, that sort of evaporate, will contribute to pollution. So there are some chemicals that contribute to global warming. The HFCs, the fluorochlorocarbons that you find in aerosol cans, the carbon dioxide that comes from the burning of fossil fuels, and other pollutants do contribute to global warming. So if you would like to try to prevent global warming, the best way you can do that is to reduce your use of power. So, and also to drive less. That would be the best way to do that. And of course, reduce your use of household chemicals that can easily evaporate. So I hope that answers your question, Diane. I'm waiting for the next question. Tara Heinzel Nelson asks, what can I do to improve local air quality? So some of those issues that I mentioned can also help local air quality. Instead of driving your car, if let's say you have a destination that's close by, you can walk to it or ride your bicycle, or if you can, combine your errands into one trip instead of taking multiple trips. You can carpool, you can take mass transit. All of those will help reduce pollution. And also, like I mentioned earlier, you could use less power. Don't run the air conditioner all the time. You can, let's see, you can use an electric lawnmower instead of a gas-powered one. You can you can paint using water-based paints. Of course, oil-based paints are sort of very limited in New Jersey nowadays. You try not to use your fireplace. I know some people like to use your fireplace, but if you can, try not to do that. And of course, try not to use aerosol sprays. But I think the most that you could do locally is to just you can drive less, use your car less, combine your trips, and if possible, walk or take mass transit or bicycle. Okay, I'm waiting for another question. Why are aerosol sprays bad? There are aerosol sprays that contain the fluorochlorocarbons, CFCs. That's what they are, and what those chemicals, they go up into the stratosphere and they deplete the ozone layer. So that is a different issue. It's all related. We want to keep the ozone layer intact in the stratosphere, which is high up in the air, 15 miles above the surface of the Earth, because the ozone up in the stratosphere protects us from the sun's ultraviolet light. But when the ozone that we talk about at ground level, that is harmful for your lungs. Okay, Brian Tsai asks, how does acid rain form? So acid rain comes from coal-fired power plants. So there aren't many, if not or at all, in New Jersey, but out west in the Midwest, there are still a lot of power plants that use coal. And when they burn coal, the emissions, some of the emissions is sulfur dioxide, and in the atmosphere, sulfur dioxide will react and form sulfuric acid, and that is what acid rain, or a portion of acid rain comes from. I hope that answers your question, Brian. Okay, so Olga from Princeton, New Jersey asks, how can I find the air quality forecast? So you can go to our website, and our website is nj.gov/DEP/airmon. That's AIRMON. So I'll repeat that, nj.gov/DEP/AIRMON. And when you reach our webpage, just click on the top right under the DEP logo, and there's a box showing the current air quality forecast for today. The air quality forecast, is color-coded so that green means good air quality, yellow is moderate air quality, orange is unhealthy for sensitive groups, and red is unhealthy for the general population. Now, when you click on that box showing the current air quality forecast, you will launch a different page on another website called airnow.gov. And from this website, you can see the current air quality for 14 areas in New Jersey. And there'll be a table with these areas, and it'll show the current air quality, the forecast for today, the forecast for tomorrow, and the name of the pollutant that's driving that forecast. The air quality rating that you see on that page, like the forecast, is color-coded in the same manner, and it'll have a number in it. And that number is sort of an index of the actual concentration of that pollutant. So 0 to 50 corresponds to good, like green, and 51 to 100 is moderate, 101 to 150 is unhealthy for sensitive groups, and more than 150 is unhealthy for everybody. Okay, what effect does air pollution have on food, crops, forests, and biodiversity? It doesn't say who asks that question, so I assume they prefer to be anonymous. But yeah, ozone, for example, is a pollutant that can harm plants. So certainly on very high ozone days, ozone is a very highly reactive pollutant, and so it will harm the foliage on plants, on trees, and so that can reduce the crop yields, and it may make trees and other plants more susceptible to diseases or harmful insects. Okay, I'm just waiting for the next question. Christine asks, how has air changed over the years? And I'm pleased to say that air quality has improved markedly in the last 20 or 30 years, significantly. We still have some issues with ozone, as we do for the rest of in the rest of the country. But for some pollutants like carbon monoxide, for nitrogen dioxide, for sulfur dioxide, and for particles and lead, we are very much meeting the standard for those pollutants, and for most of them, we're many times under the standard. I'd like to give you an example of with lead. Lead is a very harmful pollutant. It causes the reduction. It causes it's very harmful for children, for brain development, and in the early 70s, and certainly in the 60s and years before that, there were very high concentrations of lead in the atmosphere all over the United States, and that was mostly because of the use of leaded gas. And many of you may not remember leaded gas, but in the late 70s, leaded gas was removed from, rather lead was removed from gasoline, and so there's hardly any lead left in the atmosphere. It's all because it might be because from very specific sources that we have lead. But that is certainly a big success story. We have eliminated lead in a very harmful substance in the air. Justin asks, what is the biggest contributor to smog? So the biggest contributor to smog is there are two things: motor vehicles and power plants. Motor vehicles, they emit nitrogen oxides and VOCs, and power plants, for the most part, because they emit almost the same things, VOCs and nitrogen oxides. And the combination of those pollutants, when they're up in the atmosphere, they all react and they all form ozone. Margaret asks, what can I do as an individual to improve air quality in my community? And that's similar to a question that was asked earlier, and certainly you can do a lot to improve air quality. You can start by driving less. You can reduce the times that you need your car. If you have a car, you can walk to your destinations, ride a bike, take mass transit, carpool if you can, combine your errands. You can reduce your electric usage. You can reduce your use of gas-powered tools and devices like lawnmowers. And you can stop using certain aerosols or paints or other chemicals that might release VOCs into the air. Okay, the next question is, what causes indoor air quality problems? Now, I must say that indoor air is not my expertise, but you can say that there are certain things that I am aware of that can cause indoor air quality problems. The carpeting or your upholstery on your furniture might have dyes or applications of salt, either coatings, things like that, paints that can release VOCs into the air. And even using your gas stove, if it's not properly tuned, so to speak, you might be releasing nitrogen dioxide into your indoor air. So again, I'm not an expert on indoor air quality issues, but those are the few things that I can suggest that you could look into. Michael asks, how is pollution affecting what we see? So pollution, if the levels are high enough, you will be able to see it. Certainly particles, when there are many particles in the air, they will reduce your visibility. Just imagine, lighting a match, or if you see smoke coming out of an exhaust pipe of a car or motor vehicle, those are all particles. And so they will reduce your ability to see long distances. And humidity can do that as well, water vapor in the air. And ozone, depending on how high the concentration is, or in combination with particles, pollution, in combination with particle pollution, ozone and particles together can make it harder to see outside. Okay, we're waiting on the next question. Okay. Where does DEP monitor for ozone? The DEP has 16 permanent air monitoring stations that measure ozone in 15 counties in New Jersey. 10 of these stations measure ozone year-round, and 6 stations measure ozone from March 1 to October 31 every year. You can go to our website, and I think I mentioned it's the same website, nj.gov/DEP/airmon. And when you reach that site, there's a box labeled map of the latest data. So if you click on that, that'll open another window showing a map of New Jersey with circles marking the locations of the air monitoring stations. So when you click on any circle, you will get a table showing the name of the station, the pollutants measured there, and the pollutant concentration in the last hour. So not all of those circles will measure ozone, but 16 of them will. We also have an annual report. So if you're really interested in knowing more about ozone or other pollutants, we have annual reports for all the years going back to 2000, I believe. And you can get them by clicking on data on our toolbar on that website. And then you'll see annual reports on the menu. And so click on the year that you are interested in. Okay, Alex asked, what actions can businesses and industry take to help reduce air pollution? Well, if you are a business or industry that emits air pollution and you have an air pollution permit or you're operating an air pollution control equipment, of course, we would like you to use your control equipment as efficiently as possible, and if possible, reduce your emissions. That would be the best. And if you can support the use of for the employees, if you can support using electrical vehicle usage, or if you can reduce your electrical use in your facilities, but certainly the permit certainly if you follow your permit as closely as possible, and that would be the best thing that industry can do. But certainly businesses can reduce their use of electricity. That would be a really big help. And for their employees, if they could reduce their use of their cars. Natalie asks, what is the difference between ground level ozone and stratospheric ozone? And technically there is no difference. They're both the same molecule. Ozone is 3 oxygen atoms. The normal oxygen that we breathe is 2 oxygen atoms. That's completely safe, and that's what we need to live. But ozone, which has 3 oxygen atoms, is harmful. Now, on ground level, we can breathe it, and certainly and that's why it's harmful, because it irritates our lungs. But the ozone that is 15 miles above the surface of the Earth, in the ozone layer, in the stratosphere, that is beneficial to not just human beings, but plants and animals, insects. Everybody on Earth needs to have the ozone layer there because it protects us from the ultraviolet light from the sun. Otherwise, if we didn't have that ozone layer, the moment you step outside your door to the sun, you'd be instantly sunburned by the sun without that ozone layer. Okay. So one last question. Can I buy an air monitor for myself? The monitors that the DEP uses are expensive, 20,000 and up. But you can buy a lower cost or personal or portable sensor, and they run, between $200 to $6,000. The state of California has a website which tests low-cost sensors, and if you just Google AQSPEC, the first result from that search would lead you to that website. So, of course, the accuracy of low-cost sensors is not as high as $20,000 monitors, but if you are thinking about it, you might want to do some research, think about what pollutant you want to measure, where you want to collect that data, how to know if that data is accurate, and what to do with it when you're done with it. And the EPA has guidance for citizen scientists who would like to collect their own data. So you can find that on their website. That's epa.gov/citizen-science. And the DEP, our bureau, we are working on guidance for using low-cost sensors, and we hope to provide that link to a web page later this year. Okay, I think that those are all the questions that we have and all the time that we have for now. So I'd like to thank you for tuning in to Ask an Engineer and for being part of DEP's Air Quality Awareness Week. If you'd like more information about air monitoring, again, please check our website. That is www.nj.gov/DEP/AIRMON. Thanks again for joining.